Hello everyone, my name is Doug Stevenson. I'm a developer advocate with the Firebase team. I've been doing Android since the HTC G1. I really like Android. I really like Firebase too. What I'm about to talk about is a combination between Android architecture components that are part of Jetpack and also Firebase databases. If you don't know either one of these at all, it's going to be a bit like drinking a fire hose. Fire hose, disclaimer, is not a Firebase product. But if you know one or the other, this should be relatively straightforward. If you don't know either, you're going to learn a little bit about both of them, probably not everything that you need to know. The good news is that there's code. There's a sample app. You can go clone that, mess around with it. There's an app you can download and see it for yourself. I strongly encourage you to go get the code because this goes beyond typical samples that you would see from the Firebase team. For those of you who don't know anything at all about Firebase, Firebase is Google's mobile application development platform. So there are a bunch of different products. I have no time to talk about all of them, but I will talk about a couple of them. In particular, there's Cloud Firestore and Firebase Realtime Database. These are both cloud-hosted, real-time, NoSQL databases. That's a lot of keywords. Basically, your data lives in the cloud, hosted by Google. You access that data from within your app directly. So you don't go through a middleman or any sort of middleware. You connect to the database directly. They are real-time in that what real-time means is basically when some part of your database changes. So when one client writes into the database, other clients can get those notifications directly. Like you just get a callback saying that something changed, which is fairly unique, right? Because usually you query a database, but with Realtime Database and Cloud Firestore, all of these happen live. So if you're listening to a location in the database and it changes, you will receive that update. On the Firebase team, I am in developer relations, so that means we do things like documentation, sample code, videos, tutorials. We try to make Firebase as easy to use as possible. And so you end up seeing little bits of sample code that look like this. So, and I'm going to talk more about Firestore than Realtime Database because Firestore is sort of the new hotness. It's the, the sort of next gen of real-time database that Google is offering. So here in this sample, pretty straightforward. There's a Firestore singleton. So we grab a hold of the singleton. We create a reference to a document within the database. So the way Firestore is organized, you have collections, and then there are documents within that collection. Once you have a reference to that, you just call get, and it's asynchronous, and you have a callback for the snapshot for success or some failure condition. This is pretty standard Firestore sample code. The question is, though, because Firebase needs to be kind of agnostic about your development process, we just provide the basic core samples. This is how developer tools normally work. So some questions go unanswered here. For example, who manages the singleton? If you do anything with app architecture at all, you know that usually use some sort of dependency injection to manage singletons. Here, we're just reaching right into it. It also begs the question, what do you do with this asynchronous call? Get is asynchronous. It returns immediately. So how do you do asynchronous programming in your app? Not everyone does the same thing. The call is asynchronous. You just need to deal with it. We don't really tell you how. The other thing is when you set up a listener, you will get a callback. What do you do with that snapshot? Well, you can reach directly into your views and modify them directly. Is that a good idea? Well, to keep things simple, that might be what we show, but that might not be the best app architecture. Your app architecture is up to you. You get to choose whatever you want. Developer tools tend to not be opinionated about app architecture, so you don't hear any mentions of that throughout Firebase documentation. So if you are concerned about app architecture, you've probably heard of, we have all these choices, MVP, MVC, MVVM, QVC, CBS, FTP. I don't know. You have lots and lots of choices. You choose what's best for you. But sometimes people would wonder, what would Firebase do in this case? Does anyone have an opinion at all whatsoever? And it's been impressed upon me that sometimes people do want an opinion, like what is a good way to do it? Not the good way, but what is a good way to do it? Well, it turns out in Android world, the Android team has been increasingly opinionated about how to do app architecture. So now you end up with this collection of libraries called Jetpack. You have a bunch of tools to help you manage the architecture of your app. I won't talk about all of them today. There are a few that I'd really like to focus on. The two most important ones, I think, are live data and view model. So the Android team provides live data, which in soundbite terms, it notifies views when the underlying database changes. So if something changes in your database, live data helps you surface that and populate your views with that. And then side by side with that, there's something called view model, which manages UI-related data in a lifecycle conscious way. That's very soundbitey. What does it actually do? Well, I'll go into that a little bit later. But first, I'll remind you how Firebase database and Firestore work. They're real-time, which is in my opinion, a perfect fit for live data. So live data is meant to reflect changes in your UI based on changing data in your database. And that is exactly what Firebase does. Firebase data is always changing, and you want to surface real-time updates. So you can do things like build a UI that looks like this. So I don't know if you can see, but as you scroll through, you can see that stock price. So imagine this is sort of like a stock tracker app, and you have stocks, tickers on the left and prices on the right. Those prices are constantly changing. This is very, very doable and relatively easy to do with Realtime Database and Firestore. Like I said, I'll talk more about Firestore. Firestore has a particular way that you have to organize your data. So on the left column, you have a list of all of the collections, top-level collections in your database. There's one collection here called Stocks Live. Within that, there are a bunch of documents, and the list you see there are all the unique IDs for the documents. So these are just the tickers for all the various fictional stocks I have in there. And then on the right, you can see there's fields on each document, and then there's sub-collections. There may not be a sub-collection, but if you have sub-collections, they'll show up there too. If you click into that recent history sub-collection, you'll see even more documents if you have them. Here, I'm just using the timestamp as a unique ID, and even more fields within each of those documents. So that's how Firestore generally works. You have collections, documents within the collection, and optionally sub-collections within there. So my task, what I want to do is surface this data that's changing in real time. So how would you do that? Well, the simple basic starter code would be to get a hold of the Firestore instance, reach into the Stocks Live collection, grab a hold of the document. Well, we haven't grabbed a hold of it yet. We have a reference to it. And then we add a snapshot listener to that reference. You have two things can happen here. You can get a snapshot or you can get an exception. Not both, either one. If you get a snapshot, what will happen there is typically you reach into the document snapshot. It has all the fields. You would pull those fields and make a model object out of it. So I just have the stock price data class. In Kotlin, it's a data class. Just keep that in mind. And there are two properties on it, ticker and price. Keeping it very simple here. If there's an error, you should handle that. I'll be a little bit hand-wavy about how to deal with errors, but you should handle errors, right? When you have your model object, it could be very tempting to just update views right here. You can do this. This works. But this would be considered bad app architecture. App architecture, what they all generally agree on is that your data source, your data store, should be completely separate from your views. Your views should know nothing about the origin of the data, and the data should know nothing about your views. There needs to be a layer of abstraction in the middle. That's what live data does. So if all of your data is in Firestore, it's changing all the time, and you want to put that into your views, live data is that layer of abstraction that the Android team recommends that you use. A little bit about live data. They're observable, so code can register observers to receive updates. If you already understand the concept of observability, you already kind of understand most of what live data does. So for those of you who are already familiar with RX, it's basically the same thing. They're genericized, so every instance of live data has some generic type associated with it. You have to have a generic type. These are the types of objects that are going to get distributed to the observers. They're lifecycle aware. Now, this is where there's a departure from RX. RX generally isn't aware of the Android lifecycle. Live data is very aware of it. So you can handle component start, stop, and destroy states automatically, and you don't have to worry about leaks, and we'll look at examples of that. So if you wanted to keep views up to date with data that's changing in live data, here's a basic activity. This is code you've probably written 100 times over. Inflate a view, grab some text views out of it. Now what we want to do is populate those text views. So you would get a hold of a live data, and again, I'm being a little bit hand-wavy about where this live data comes from, but let's just say you have a live data that came from somewhere. That live data is going to reflect prices or changing prices in your fictional stock. You set up an observer with that. So you'll notice the first parameter of this is kind of unusual. It is an activity instance. Now, you may have been coached for a very long time to never pass around activity instances. You don't want that activity to leak. Live data is different. Live data needs that so it can be lifecycle aware. It is going to track the lifecycle of this activity. And then you also pass an observer to it, and that observer basically is the callback mechanism so that you can receive these stock price updates. And then you check to see if you have one and then update your data. This is better, right? There's no mention of Firestore anywhere in this activity. You could be using Firestore, you could be using Realtime Database, you could be using SQLite, whatever your data store is. It doesn't matter because it's all been abstracted away behind the live data. This is good. But I still haven't said where you get one of these live data objects from. And we'll talk about that in a little bit. It's worth mentioning that live data is aware of the Android activity lifecycle, and as such, when your activity is stopped, it will automatically stop observing. So all of those observers will just go away and not receive updates. When your activity is started again, all of those observers that were originally detached become attached again. So you don't have to worry about excessive updates happening when your activity has just gone away. So maybe the user has pressed home, the activity has stopped, observers stop receiving updates. the user goes back into the app, you get updates again. And when the activity is finally destroyed, all of it is garbage collected. You don't have to do any sort of manual detaching or anything like that. It just happens automatically. So you reduce a lot of boilerplate code by using live data. So if we wanted to implement a live data that receives these stock price updates, the first thing we would do is subclass live data and give it the generic type that we want. So we want stock price objects, that Kotlin data class. What we're going to do with that is we need to pass into the constructor a document reference. Now remember, that document reference points to that one document in the database that is constantly changing, and we want to receive updates from that one document. So there's two methods you need to override in live data. The first one is onActive. This happens when the number of observers on this live data goes from 0 to 1. That means something is interested in this data. So what we need to do, now that someone is interested, is start listening. So we add a listener here, and that listener is going to return a listener registration object. We need to hold on to that for later. The second method we need to override is onInactive. So when the number of observers goes from 1 to 0, that means nobody's interested in this data anymore. And what we'll do is just remove the listener. So we won't incur any sort of data charges persistently. It's only active when someone is actually interested in the data. Now, there's a missing detail here. When you add a snapshot listener, you need a listener object to handle that. So what I'll do here is just make this live data its own event listener. So I'll implement the event listener interface, and it will receive document snapshot objects. And so now we have a new interface method to implement called onEvent. And onEvent looks like this. You'll receive either a snapshot or an exception, as you've seen before. What we'll do is, if we get a snapshot, we'll make sure that there's data in there, and then populate a stock price object. And after that, this is a very unique method on live data. So once you have your data object that you want to send to all the observers, you call setValue on the live data. You pass it the object you want. This does two things. First, it's going to retain that model object. So it's going to hold on to that until the value changes again. And it's also going to broadcast to all the observers that the object changed. So this is how it broadcasts all of your updates to your UI layer. And your UI layer will, of course, render the data. And, of course, when there's an error, you should handle it. Again, I'm being a little bit hand-wavy about that, but that's okay. There's two problems with this live data implementation. It's okay, but there's a couple things I'd like to resolve. First, we never really said who creates this instance of live data. The problem is that, as you saw, stock price live data, that implementation requires a document reference object. That's an implementation detail. We don't want to put that implementation detail in the activity. We want to keep that completely abstracted away from the activity. Again, the activity, you can think of an activity as a view. It's a container for views. That activity should know nothing about Firestore, so the activity can't make it directly. That's what I just said. The other problem is that the live data will lose its data on a configuration change. So I'm sure you all know, if you have a configuration change, for example, would be orientation. So when you go from portrait to landscape, your activity is gone, it's destroyed, and then it comes back, a whole new version. You have to sort of reconstitute your state from that. Live data along with it. Live data will just go away. But I'd really rather not lose all that data that I actually had in my last instance. I'd rather retain it. So what you can do to solve this problem is use viewModel. So viewModel is another Jetpack component that survives configuration changes. So the same viewModel instance appears in reconfigured activities. So your old version of the activity can basically pass along its viewModel that it had to the new one. You don't lose any of that state. It's a great optimization. View models are shared and managed, so Jetpack just handles everything. You don't really do anything to manage it. You just ask for them, and you'll see an example of that. And these are also lifecycle aware. So they're automatically cleaned up when the activity has gone away permanently. So when the finish method is called, or when your activity goes away forever, the view model that was associated with it will also go away forever and get garbage collected. So to illustrate this a little bit better, imagine that you have an activity, the views are updating in real time, everything's great, and then you have inside that a view model which contains a live data. So this live data, you can think of that as sort of updating, it's responsible for updating all these views. Everything is great, you have an orientation change. Well, of course, the activity is going to go away and come back in landscape. Now, how does this landscape version reconstitute its state? Well, Jetpack steps in and says, hey, view model, you go over there. So it's the exact same view model, the exact same live data, but just now it's in a different instance of the activity. Super handy, right? So that's kind of how it works. You can think of it as a persistent state for your activity, no matter how many configuration changes it goes through. So how do we want to implement one of these? Well, the first thing you do is subclass view model. I'm going to create an API method on that called get stock price live data, and it'll take a ticker, and that's the thing that we're interested in tracking, the stock price we're interested in tracking, and it'll return a live data that we can use to update our views. What's going on here? Okay, so I'm adding another layer of abstraction here. I'm creating what's called a repository. A repository is going to contain all the details about Firestore. This view model isn't really going to know anything about Firestore, and that's okay. We've delegated that all to the repository. You can think of the repository as basically a data access layer. So there's an interface. Imagine there's an interface there called stock data repository. And this could be backed by Firestore, a Realtime Database, or SQLite, or what have you. But the important thing is you have one of these, and maybe think about adding it through dependency injection. Now, we're going to ask the repository for a live data object and return it. So we're actually kind of acting as a middleman. There's one important thing here that your view model should do, and that's cache that live data. Hold it internally so that when you have a configuration change, the view model, along with all the live data, get associated with the new activity. And I'm not showing this code here. Imagine there's a map that maps tickers to live data objects. You maintain that yourself. It's just boilerplate code. But this is what I do in my app. A little bit more complicated, but it works pretty well. So if we want to implement a repository backed by Firestore, remember we have this repository interface. We still need something to actually deal with Firestore. I'm going to implement this interface, override the get stock price live data method, reach into the Firestore singleton instance, and again, consider dependency injection for that. Then I'm going to construct a reference and then pass that on to the stock price live data that you saw earlier. So now we have a bunch of components all working together. In fact, I consider it a team. You have live data that's distributing real-time updates as they happen from the database. You have view model, which is acting as sort of the mediator between your various activity instances, and it's holding on to a live data object for you. You have a repository, which is your abstraction for your data layer, and then you have Firebase backing the data. So between these four things together, what we've done is effectively implement this diagram, which you see in the Android documentation, except there's one thing: we're not using room as a persistence layer. We don't really need room here because Firebase has its own local data caching. So when you do a query, when you pull down documents, when you read data from database, it gets cached if you want it to. So we don't need a persistence layer. You can add one in. There are reasons why you'd want to do that, but I don't need to do it in this case. And instead of an API interface to some other service, you're just using Firebase APIs instead. So this is what I've just implemented. Very, very simple, very, very straightforward. In my code, I actually go a little bit further than this, but this is pretty good architecture. So in order to use view model and live data together in activity, again, we have our boilerplate, inflating views, grabbing views out of them. Now what we're going to do with this team is we're going to say, hey, view model, I'm not going to say, hey, view model. I'm going to say, hey, Jetpack, I need a view model. This little bit of code is kind of interesting because there's some magic going on in here. This view model providers class provides a static method called of. You pass it an activity, and it creates a new view model for you if there hasn't already been one created, and it will retain that. So you don't have to write any code to figure out how to instantiate your view model. You can if you want, but here I'm just allowing Jetpack to do all the dirty work for me. Once I have my view model, I'm going to pull a live data out of it for the ticker I'm interested in, and I'm going to observe, just like you saw before, passing in the activity instance and creating an observer and populating my views from there. Notice that Firestore is gone from this. It's just not present. That's good. So we've fully separated our views from our repository. So I think it's a pretty good pattern. But we still haven't dealt with errors yet. I mean, as we've seen before, when you get a snapshot, it's either a snapshot or an exception. You kind of have to think about errors. I haven't really shown how to do that. So what do? Well, live data doesn't propagate errors by default. Live data doesn't have an error state with it, so you need to add errors into it if that's what you want to handle. They need to bubble up to the UI. Your UI at some point needs to show an error if something happened, right? If you can't get the stock quotes for whatever reason, the user should be notified of that. That would be kind of silly not to show them anything at all. So what I do in my code is I create a data class called data or exception. It either contains the data that you're looking for or an exception, one or the other, not both. And then what I do is I type alias that so it's a little bit easier to understand. So what I'll say is a stock price or exception is either a stock price object or an exception object. And that's the thing that I'll use in my live data. So instead of live data of stock price, I'll have a live data of stock price or exception. And then when I receive updates, I'll check to see is there an exception or is there stock price and update my UI accordingly. So right now we have a pattern for doing one document in the database, which is not really that helpful. you're probably interested in a query. You probably want multiple documents. So how do you deal with queries? Well, I remind you that Realtime Database and Firestore, not only can you listen to locations, but you can listen to entire queries. So if you query Firestore and you would get back a collection of documents, if any one of those documents changes, you'll get a notification. If the query set changes, like if there's a new document that satisfies the query, you'll get an update for that as well. And this is really great for building very, very real, like live UIs. So I'll do a quick Firestore query primer. If you don't know Firestore, this will be helpful to get up to speed. So what you do is you grab the singleton instance, reach into a collection. Now you could say, within that collection, say, give me all the stock prices or stock items that are greater than 100. So now we're sort of filtering. We've got a filter on this query. So of all the documents in this collection, I'm interested in a subset of them. I want to order them by price. So now you can do filtering and ordering. Which is super handy, and I can say I want descending instead of ascending, so you can sort both ways. Firestore does this, Realtime Database does not. Just bear that in mind. Then you can call get on the result of that query, and that gives you all of the documents in one fell swoop, and then you can set up a listener on that to receive that. Now this is a one-time fetch. This isn't like a persistent fetch. If you want to constantly be reminded of updates to the search results, what you'll do instead is add a snapshot listener on that query. And that query, you'll pass it an event listener. And that event listener is going to look something like this. So you implement an object that implements the event listener interface. You want to receive query snapshot results. And in your on event, you have to deal with a query snapshot or an exception. So here, one of the things you can do, and it's very tempting to go down this road, you can listen to individual updates from that query. So this listener will get called anytime a document is added to the result set, or changed, or removed. The first time it gets called, you'll only get add events. You'll get all of the documents as they are initially sitting in the database. You can get another added event after that as more documents are added that satisfy the query. Or if anything is deleted, you'll get a notification about that as well. It's very tempting, but there is one problem. Live data doesn't support deltas. Live data is entire results all at once every time. So if you have deltas coming in, you kind of have to compress them all down and add them to a single result set. So you can't do that. You might think, well, what you actually want is a list of stock price objects, which is good, but that doesn't really account for errors. So we have a live data with data or exception and a list of stock prices or an exception. So now we're getting a little more generic. I go even further. What I want to do is add in, and you'll notice between the last line and the next line, there's a new abstraction called query item. And query item is basically saying, I have an item and it has a unique ID. Now, I'm not going to explain right now why I add this abstraction in. It'll be more clear later as we use this to populate a list view. But this is exception hell. Sorry, this is generics hell. We're 4 deep right now. This is not easy to reason about. It's not easy to read. It's not even easy to type. So let's escape this generics hell. Let's use Kotlin. So Kotlin has something called a type alias where you can create a new type that's based on some other type. So what we want to do is create a query results or exception type and make that a data or exception, which is a list of results or an exception. So we're getting a little bit easier. We can make this even simpler for stock prices, where you can say a stock price query results is either a list of stock prices or an exception. This is a little easier to reason about. So now our live data can simply generate objects of this type. Easier to think about, easier to type. It's hiding some complication that you don't want to type every single time. So this is what I do in my code. So let's implement a live data that deals with Firestore queries. So, and this is generic. This is for any sort of query. This is a reusable component. So what we would do is create a type alias called document snapshots or exceptions. So either this thing is going to generate a list of document snapshots or an exception. So to implement this, we would subclass live data. We, of course, have onActive and onInactive. And in onActive, we're going to listen to the results of that query. The query is passed in through the constructor. And when we're active, we do the query. When we're inactive, we stop the query. And of course, we need to be our own listener, just like before. And inside on event, what we're going to do is, instead of looking at the document changes, we're just going to look at the full results of the documents themselves. So if you have 10 documents, I just want those all of those 10 raw documents. Then we'll package them up and call, what is that? Post value to get, gosh, I can't even read my tiny little font here. So we're going to get a list of documents from the snapshot and then post that to the live data. So this is generic. This works for any sort of Firestore query, but we want to actually make this relevant to stock prices. We want to get the stock prices out of that. And I won't show the code for this. It's fairly mechanical. What we need to do is transform this live data of a generic document snapshot type into a strong type. And so basically, you need to deserialize that document. I won't show the code. Go into the repo, see that for yourself. It's mechanical. It uses something called mediator live data to do that conversion. So if you have a live data that generates one type of thing, you can use a mediator live data to convert that into another type of thing. And in my code, I actually do all of that mediation on another thread. So all of that deserialization won't cost you time on the main thread. You can observe that live data and then update your recycler view adapter. So you have a list of items and you want to stick it in a recycler view. Pretty straightforward. Most of you who have worked with recycler view know that when your data changes, you call notify dataset changed. That tells the recycler view, or sorry, that tells the adapter, hey, something changed in my data. I need to change the recycler view to suit. But if your results are constantly changing, like if you have stock prices that are changing, or maybe the order of things changing, this is kind of janky. If you don't tell it what specifically changed, the entire thing will be redrawn. That's not a very good experience. I actually tried this. I went down this path and found, it's like pretty terrible performance. There's one thing you can do to make this work a lot better. I discovered, and this was new to me, there's a thing called list adapter in the recycler view extensions library. What list adapter does is kind of magic. It's actually going to do a lot of work for you, and I'll explain a little bit. I dug into the code. It's fairly complicated. All you have to do is call submit list with your list of data, and what it will do is it'll diff the prior list and the new list. So it'll look for objects that have changed or been added or removed. It does all of the dirty work to figure out what actually changed between these two lists. And it will let the adapter know specifically what happened. And the adapter can respond and say, oh, I need to render this one row, or I need to change this one view. It's highly optimized. This is fairly slick. There's one catch. You need to subclass one base class. And the implementation is fortunately so simple in Kotlin. You have to implement something called a diffutal item callback. And this item callback, actually I'm showing you now not Kotlin, but Java. This is pulled directly from the item callback source code. So an item callback basically says, it's going to ask, are items the same? So you pass two items, and you have to tell it, are these items actually the same item? If they're the same, the list adapter is going to say, well, are the contents the same? So you tell it, you look inside the objects and say, do they contain the same data? If so, you return true. You can go even further and tell it specifically what items of data changed within that. And I don't use that. The default implementation is null. But you're obliged to basically say, are two items the same, and do they contain the same contents? So now I'll go back to that abstraction I added earlier. Remember, I added query item into that sort of generics mix. Now query item is very, very interesting because it gives me an ID to compare between two objects. So if I get two objects, all I have to do is look at their IDs, and if they're the same, then I know they're the same object. The ID here is just the Firestore document ID. They're immutable. They never change. They're always staying the same, and that's how you know if an item is the same as the query changes. So the implementation is super simple. Are items the same basically says compare the IDs. If they're the same object. To compare the contents, I'm taking advantage of a great Kotlin feature for data classes. So if you don't know, data classes have a magical equals method that will compare structurally to data classes to tell if all of their fields are the same. That's all I have to do here. This is the only thing. So for all query items that all contain data classes, this implementation will work for every single one of them. That's really, really handy. So I use that throughout my code. The one catch is you have to be using data classes, which is not that bad. It's actually very convenient. So all this said, you can implement an interface that looks like this. So this is the stock history collection for one of my tickers. You can see that this is a recycler view, and the list adapter is comparing all of the query updates that it's getting and telling me, oh, you have a new document. It's sorted first. Move everything down. That's all the work you have to put into making an interface like this. Now, practically speaking, you'd want a graph instead of a scrolling list like this. But that said, if you have a scrolling list that would be served by live data and recycler view with the list adapter, this works really well. So just because you can make UIs like this doesn't necessarily mean you should. I'm just going to be opinionated a moment and say, well, do you really need live query results? Is that really what your UI needs? I mean, you can do it, but is it worthwhile? They're fun to watch, but possibly bad to interact with. So when you think about it, imagine your users want to click on one. They're told, if you want to drill in deeper, click this item. Now imagine they're all moving, and you never know which way they're going to move. That could be very frustrating from a UI perspective. So don't feel like you should have live query results if it makes your app unusable to do so. It's probably not so bad for append-only results. So if your list only ever grows and you add new elements, probably not a problem. Things are not maybe shifting around so much. Instead of having live results, maybe use a refresh indicator. So if you're using live data, maybe the first update you receive to a live data, populate the list. Maybe hold on a second, don't render anything new. If you receive an update to your live data, consider showing like a refresh button to show those updates. So again, this is just opinionated. I'm not a UX expert, but I'm pretty sure I would not like to try to click on things that are constantly moving around. Okay, so I've talked about live data, view model, I've talked about repository, I've talked about Firestore documents and queries, live updates. This is all great, but what if you want to do background sync for offline use? Well, live data isn't going to really help you. Live data is more about getting items from your database into your views. If you want to do a background sync, there's another Jetpack component for that. And I will say that here's a use case. So take our stock tracker, for example. Say you want to browse stock prices after the market closes. So markets close on 4 p.m. Weekdays. So imagine that you go home at 5 p.m., you want to browse your stock prices, but you're in a subway and you don't have any connectivity. Well, what do? I still want my app to be usable. I feel like I should be able to use my app, but I don't need real-time updates. I'd rather just view cache data. It turns out, like I said, Realtime Database and Firestore have offline caching built in. So when you query for data, it will be on the device, in the app, ready and waiting to go. You don't need a connection to query it. The question is, how do you sync that data when the app isn't running? Obviously, when the app is running, it's going to be connected. It's going to be doing whatever it does to query. But if the app isn't running all the time, and you can't expect your users to be running your app all the time, what do? Well, we need to schedule some sort of a data sync. That's pretty easy to do. You have two choices for background sync. Just in theory, the app could poll for updates. So periodically, the app could say, hey, server, give me updates to my stock data. Or you could have the server tell the app when there's an update. You could have two choices. I'll go over both of them. But in both cases, Jetpack's Work Manager will help you out with this. So with Work Manager, this component lets you do scheduled work. So you can indicate a time that you want to sync and a period. So hourly, daily, however often you want. There are constraints for Work Manager, and it indicates the conditions that are necessary in order to execute this job. So if you know your job needs network, you should say, I need network, or I need a reasonable amount of battery. And there's also work chaining. So what you can do is, if you have a complex set of tasks, and the results of one depends on the results of another, you can chain. And I don't do anything like this, but you can do this if you need to. So let's take that first example where you want to schedule periodic work. Let's say we're going to ping Firestore and say, hey, give me the latest updates. What you can do is create a constraints object and tell it, I need to be connected to the network and I need decent battery. I'm not going to be a jerk to my users and make them waste battery when just for stock updates. The other thing we're going to do is create a periodic work request builder. So what this does is it lets me determine how often I want to do this. So right now I'm saying this is every day. It can be whatever you want. And I'm going to tell it the constraints for the job. And after I build that, I'm going to send that off to, oh, I went too far. Yeah, so the generic type of this is the implementation class of the thing that's going to do the work. This is a little bit of Kotlin syntax right here. You don't have to new this thing up for it. You'll just new up an instance of that and let it do the work. And you go off to Work Manager and say, enqueue this work, periodic work. We're going to give it a unique ID to identify this work. And we're going to say, if there's already something scheduled, keep it there. Don't override it. That's what this is saying here. Now this will work. You could poll for updates, but I don't think this is the best option. I think that periodic work is problematic because it doesn't have exact schedules like cron. So cron, you can do something daily, hourly, whatever. You can schedule it on the hour if you want, but you can't do that. Well, it takes a lot of extra work to do this. You can have an overzealous sync period, so you can poll more often than you want in order to get fresh data, and that's just kind of wasteful. You could code up something that tries to delay work on the schedule that you want, but that's, again, is just more work. The client must know when markets close. Now, we all know that markets close at 4, but there's actually this thing called after-hours trading, where stocks continue to get traded after closing. And I want the final results. I don't want the 4 o'clock close results. I want the after-hours. What I want to do is server push instead. So what I can do, presuming your backend knows when the trading day is finally over, you can push an update to clients saying, hey, you should poll now. The server knows when the trading stops, but the app doesn't have to schedule anything at all. The app is just being told, hey, something changed. You should go, get that update. So what I like to do here is use Firebase Cloud Messaging to notify the app. So it's just push notifications, relatively easy to implement. So when the app receives a notification, the app will schedule a sync with Work Manager. So you can do a one-time request and tell it, now, go do that sync. To visualize this a little bit, let's say you have a couple of apps, a couple of instances of your app. One app is interested in ticker 1 and ticker 2, and the other one's interested in ticker 2 and ticker 3. Well, how do we know which ones to push which data to? Well, you can use topic messaging for this. With topic messaging, you can say, create a topic for a ticker, push a message to that topic, and all the apps that are listening to that topic will receive the update. So that's probably the way I would do this if I had to do it quickly and easily. So to implement message receipt, and I'll go through this real fast because I have just a couple minutes. There's a service that you can subclass, Firebase Messaging Service. This is a regular old Android service. What you do is there's a single callback in there called onMessageReceived. The remote message will contain the data from the push. Let's just say that we get the ticker from the message, so there's a JSON payload. The ticker is in the JSON payload. We'll pull the ticker out of there and then schedule a sync. To schedule a sync, all we have to do is create some constraints like we did before for Work Manager. We'll create a data payload for the job. So this data payload is basically here to let Work Manager serialize the job if it needs to. So you have to create this work data. It's a data object you call get the data, build it, and then pass it off to Work Manager. So this is a little bit different than scheduled. This is a one-time work request. We're going to give it a unique ID based on the ticker name. We're going to tell it and that's all you have to do. So the worker itself, there's a method on it called doWork. So if you subclass worker, there's a method called doWork. You have to do your work synchronously. This is a limitation of the Work Manager API right now. So as you recall, all the Firestore APIs are asynchronous. They return immediately. So you have to turn those asynchronous APIs into synchronous APIs. So you have to use like a countdown latch in order to block this thread so that it completes its work and can return a disposition to Work Manager. I've talked with the Work Manager folks. They're actually open to making it more asynchronous friendly. So maybe in the future you could return a future that indicates when your work is done. Okay, I'm out of time. There's lots more in the repo. Go get the code. The code is there. Please go clone it, study it. Let me know if you have any feedback. There are implementations for both real individual documents and nodes and queries. There's also examples for paging, so you can do, in theory, infinite scrolling with Firestore and Realtime Database. Paging is another Jetpack component that I just don't have time to talk about today. It is kind of its whole own talk. There's a backend implemented in TypeScript using Cloud Functions, so I actually work very closely with the Cloud Functions team. This is how I make all of my stocks update in real time, how I fake their updates. I have that can be added to Firebase UI to make dealing with Firestore and real-time database queries and documents and nodes super easy in conjunction with view model and live data. So stay tuned for more. Thank you for your time. Go